and I'll share my screen. So if you can see the screen, please say yes in the chat. If you cannot, say no. So I'm going to share my screen now. Okay, so you should be able to see the slides, right? So please say yes or no in the chat if you can see the screen. Yes, okay, very good. So everybody can see the screen. Let's just begin. Lesson 2.1. So we're going to start a new unit. First unit, very easy. Extremely easy stuff. Order of operations. Today we will be doing a little bit harder stuff. This is we're getting into the actual backbone of algebra, linear equations, right? When you think of algebra, you think of linear equations. Today, that's what we're doing. Okay. All right, so today we will be going over our homework briefly, and then we will be reviewing some substitution. We will then go into some inverse operations, and finally, how to solve linear equations with some examples. All right. Let's start with the first one. I'll give you like a couple moments to do this, and then please raise your hand to volunteer, okay? Later on. So please raise your hand to volunteer, or I will call on you. So please be ready with your answer for this problem. It should not be too hard. Okay, so let's go over this one real quick. Let's see who got it. Okay, let me give you a bit more time to do it then. So like 1 more minute to do this. That's just easy substitution. So if you paid attention last class, you should be able to get this. So I'll give you like 1 more minute to do this.
我现在几点钟那个去游泳？
2点半。你不要讲话，你讲话让老师听到。
Okay, so I'm gonna go over this real quick. So who can volunteer? So can somebody unmute yourself and volunteer? Okay, so who wants to volunteer? Andrew, are you there?
Yes,
You know how to do this problem?
I just
So
joined. Sorry, I couldn't see.
Oh, okay. So well, you can just do it now. So how did you do this homework problem?
That is -7 1/2.
Okay, so let's see how we did it. So you just have to substitute -1/3 for t, right? So what is 12 times -1/3? Andrew? -4, right? And then minus 34 over 4. So what did you get?
Oh, okay, I see.
Or what is the top?
Huh?
What is the top? What is -4 minus 34?
9 1 over 2.
Oh, just tell me what is -4 minus 34 first.
38.
-38, right? So that's over 4, and then we can simplify. So we get negative, what is this? 19 over 2. That's all you need to do. Please do not do anything extra. You do not need to. Let's just keep it as an improper fraction. That's what people do. Do not make it into a mixed fraction. Do not make it into like -9 1/2. Don't do this. People don't do this at higher levels. We always use improper fractions. They're easier to work with. Okay, so now let's go to the second problem. All right, this one is a bit more complicated. It has two variables this time. Okay, so Denny says 25. So, Denny, can you share with us how you did this? So, can you unmute yourself? Thank you very much.
So I did this by so B is 8 and then I added with 1 and then W is 3/5, so I timed it times 2 like with the exponent, which gave me 9 over 25. You cannot divide it, so you multiply it, and then it's 9 times 9 over 25 would equal 25.
Okay, very good. So, as you can see, what you have to do here is you have to flip this fraction, right? So, we have 9 times 25 over 9, which is just equal to 25. So, very good. Okay. So, whoever got 25, good job. Now let's go on to number 3. Evaluate 3u minus 2v minus 13. If u is equal to -2, v is equal to 4. So please do this. Okay. So let's see who got this. 7 answers. Very good. So we have negative 27 and negative 31. That seems that most people got negative 27. So whoever got negative 27, please raise your hand or to volunteer, or I can call on someone. Can you volunteer to solve this problem? Who wants to volunteer to solve this problem? Okay, so let's ask Michelle this time. So Michelle, can you unmute yourself and tell us how
Yeah.
we got this?
So, if it's like 3w minus 2v minus 13, you replace the u and the v, which becomes 3 times negative 2 minus, like in brackets, yeah. Minus 2 times 4 minus 13, which becomes negative 6 minus 8 minus 13, which you get negative 27.
Very good. So as you can see, we get negative 27 here. So whoever got negative 27, very good job. Simple substitution. So let's go on to the next one. Let's make this fast. All right, this one is just, true or it's just multiple choice. So yeah. Okay, so I'll give you a couple moments to do this. All right, so let's go over this problem. I'm just gonna go over this real quick. So a, as we can see, we can just plug it in. We get negative 1 squared plus 2 to the negative 1. All right, 2 times negative 1. We get 1 minus 2, which is equal to negative 1, which does not equal to 3, so that is not true. Okay, so let's see. B is r. Actually, just negative 1. 1 over 5 plus 5, which is equal to negative 8, which is obviously, okay, does not equal to negative 8, actually. It's not equal to negative 8 here, so that is false as well. C, I think, should be the correct one. So let's see here. Negative 1 minus 1 over 2, negative 2 plus 1. As you can see, we have negative 2 times negative 1. So we have positive 2, which is correct. Now let's just check D. This is just negative 1 cubed minus 3 is equal to, does not equal to negative 9. So as you can see, C is the correct answer. So whoever got C, very good job. Let's see who got C. Okay, so some people said B, and some people said D, and the answer is C. So if you got C, good job. Okay. Number 5 is determine the validity of the statement a squared plus 7a plus 2 is equal to 37. Okay, so same thing. Plug it in and verify if it's correct or not. All right, left side should be equal to the right side. More on that equality later. Okay, so let's go over this one. Determine validity of the statement. All you have to do is to plug in 2 for a. Okay, so let's find a volunteer to do this. Let me see here. Annie. Okay, very good. Thank you for volunteering, Annie. How did you do this? And what is the answer? Can
So,
you
if A is 2, then that just means that 2 to the power of 2 plus 7 times 2 plus 2 is equal to 37. So then that's 4 plus 14 plus 2 equals to 37. And then if you add it up, it's 20, and 20 is not equal to 37.
Okay, so the answer is false here. So whoever got false, very good job. Okay, the answer is false. Okay, so that's it for our homework questions. As you can see, it was not that hard. So yeah. Now let's review on variables. So since this is a review, I want more people to participate. So let's see, just get a couple bullet points here. So can everybody in the chat type in something about variables that you learned last week? All right, something about variables, and let's see what you remember about variables. Like the exact definition of variables. What exactly is a variable? So let's see. Yeah, it's a placeholder. Very good. So Ivan says it's a placeholder stands for unknown number. Okay, very good. The placeholder for an identity. All right. In fact, it does not have to be a placeholder for an unknown number. All right, it's not required. It can be a placeholder for another variable. In fact, for example, x can be 2y. X is the placeholder for 2y. It doesn't have to be x is equal to 3. All right, variables can be anything. They're placeholders for anything you want. All right. Okay, so, but it can be an unknown number. All right, we will be using variables as unknown numbers as we go here. All right, today we will be learning about linear equations in which these variables will be unknown numbers. So now, what else? Does anybody else have any ideas on what a variable is? So any more ideas? Okay, so I'll just add that variables can be anything. Okay, so it can be x, and could be y, it could be z. Doesn't matter, as long as you know what the variable defines, it's good. But I would like to add a little disclaimer. Please use reasonable variables. All right, don't use like a heart symbol for a variable, right? You're probably not going to understand that. For example, let's say that you want to have a variable for price. You'd probably use p, right? P for price. Maybe you have a variable called earnings. Maybe that can be denoted by e. See how it's easier to understand? Right. So you don't have to use x or y for everything. So you can probably choose your variables so that you can understand them better. All right, so now let's go to our introduction on linear equations. So what exactly is an equation? All right, so let's see what everybody knows about what an equation is. So please go to the chat and type in, what do you think an equation is mathematically, algebraically, right? So any ideas on what an equation is, right? Has an equal sign, right? It actually can't have an inequality, actually. It has to have an equal sign, all right? Equal sign, right? It sets two, all right, or more expressions equal, all right? For example, x is equal to y. In this case, all right, let me just give some examples of what, a linear equation might look like. X is equal to 3. As you can see, we have two expressions here, x and 3. Or maybe we have 2x plus 4 is equal to 5 times x minus 1, all right? Or maybe we have x squared minus 4 is equal to 1. As you can see, we just have two equations or two expressions set equal to each other. That's a linear equation. An algebraic linear equation is just that with variables, all right? Algebra includes variables. That's why variables are important, all right? So, as you can see here, now we need to know how to solve these equations, right? So, how do we actually solve these equations? All right, let's talk about that on the next slide here. How do you solve with inverse operations? So first of all, to solve an equation, right? To solve an equation, you must have what? You must have the variables on one side and the numbers on the other, right? You want to have it into this format, right? So let's look at this format. You might want to have it into x is equal to a, where a is equal to a number. Right, where a is a number. So you want to isolate the variables and the numbers, right? So key point here, a very key point. So everybody take your notes. Isolate the variable from the numbers. When you have, for example, x squared minus 5x plus 1 is equal to, like 2x. You can't find out what x is. But when you have it in this form, x is equal to 4, wow, you know what x is equal to. It's equal to 4, right? So you need to manipulate this first equation in such a way that it becomes x is equal to 4, or it becomes x is equal to 5, or something, right? You need to use inverse operations to manipulate this equation to get into this format. That's how we solve for variables, to isolate the variables from the numbers. So now let's talk about what exactly is an inverse operation. It's nothing too new. It's basically just your regular order of operations, but the opposite of it. So let me just give you some examples. So everybody, actually, let me give one example. Let me give one example, and then you guys do the rest. Okay, so one example, inverse operations. Let me just use a different color for better separation here. Inverse operations. Okay, that did not change. Inverse operations. Okay, so one of them is addition and subtraction. You see, the name implies that these are inverses of each other. They cancel each other out. What happens? All right, what happens when you 4 plus x minus x is still equal to 4, right? Inverse operations, addition and subtraction, cancel each other out. So now that you kind of know what an inverse operation is, can you type in the chat and give me a couple more inverse operations, like in pairs, all right? So please type in the chat what you think are some pairs of inverse operations. Okay, so please type in the chat. I'll give you like 1 moment to think about these inverse operations and what other pairs of inverse operations there are. All right, things that cancel each other out, right? There's 2 more pairs that we will be working with in this course. Okay, so has everybody thought of something, right? So division and multiply, very good. So whoever said division and multiply, very good. So as you can see, these cancel each other out, right? Division and multiplication. Okay. So then we can have let me just give an example of how that works. You see 4 times 3 divided by 3 is still 4, right? See how these cancel each other out? That's inverse operations. So now we can do power and root. All right. So let's see. Give an example here. As you can see, square root of 4. And then square that. It's still equal to 4, right? So these cancel each other out. These are inverse operations. So make sure you take note of all 3 pairs of these inverse operations. All right, they are very important. So let's go to our first problem here. All right. I'll give you actually let me do an example first. Okay, let me do an example first. So let me just find some spot to do a quick example of how you can use inverse operation. All right. So let me see. Let's just say 4x, and since we are pretty early on the time, if we do run out of practice problems, I will just quickly just make up some more, right? So we have 3 minus is equal to 5. All right, so how do we use inverse operations? So what we got to do is we got to isolate we have to isolate the variable from the numbers, right? So we have to move 3 to this side and keep the x here, right? We want to keep the x here, move the 3 to the other side. So what we have to do is we have to cancel out the 3 on this side, all right, by subtracting 3 as equal to 5. Okay, so, but this is an equation. It always has to be equal when these expressions are set equal. When you operate on these expressions, you have to do it to both sides. So when you subtract 3 from this side to get rid of 3, you have to subtract 3 to this other side too. So as you can see, these are now canceled out, right? So 4x is equal to 2. Well, how do you get x? Since it's 4 times x, you got to isolate that too. You have to divide by 4. Let's divide by 4 on both sides, and what we get here is x is equal to 1/2. All right, so that's our answer right there. That's how you do it. All right, so that quick example. So now you can try on your own. This one is not too hard. All right, this one is not too hard. So try on your own here. All right, so I don't know. Okay, so x is equal to 7. Very good. I think most people can get that using some simple inverse operations. The homework will be harder than this. Okay, so be prepared. So how about who got the answer? Let's see who got the answer, and I'll ask you to volunteer or something. Okay, actually someone got x is equal to 2.1. I don't know how you got that, but that's interesting. So Yu Chen, can you unmute yourself and help us solve this? Are you there, Yu Chen?
Oh yeah, so for the question, you first distribute 4 into the group x minus 9, and then you get 7x plus 4x minus 36 equals 41. And then 36 plus 41 equals 77.
Okay.
So 11x equals 77, and then x equals 7.
Very good. As you can see, here's what we have. So for anybody confused, she did it quite fast here. That's very good. So what we did here is we actually added 36 to both sides, right? That's how we cancel out this 36 on this side, and then we have x, we just like this, and then we have 77 here, and then he just combined, right? Combined like terms. I'm pretty sure you all know how to do that. So to this, we now have to divide both sides by 11. X is equal to 7. Okay, so very good, very good. Okay, so I'm just gonna give you a couple, like about more minutes, some more minutes to do this problem, and then I'll give you some harder ones. Okay. Okay, so I'm just going to start checking these answers. As you can see, we have let's see. People said x is equal to 9. Some people said 8 over 77. Crazy. I don't know which one. So it seems we have a split between 9 and 8 over 77. So let's see. What is the actual answer here? So who gave an answer? How about Aaron? Aaron, can you unmute yourself this time and volunteer to solve our problem here? How did you do this problem?
I first multiplied 3x by 2 and 5 by 2.
Okay, and what were those
And
equal?
3x times 2 equals to 6 and 5 times 2 equals to 10.
Very good. So now what do we have to do?
We have to subtract 10 from 82.
Okay. So very good. So what is 82 minus 10? That is 72, right? So what do these combine to?
8.
8x. Okay, so we have 8x is equal to 72. X is equal to what? It is equal to 9, right?
9. Yes.
Okay. So I don't know, how did people get 8 over 77? So let's see who got 8 over 77. Yuchen, can you unmute yourself and tell us what
Okay, so
what is
the reason why is yeah, I forgot how I did it.
Oh, you probably looked at the numbers wrong, right?
Yeah.
Okay. But you did the same process, so that's very good. Because it's just I don't know. I think you just did some computational error, but as long as the process is good, you can always go and fix the computational errors. The important part is you understand the inverse operations, and we are out of problems. We have 15 more minutes, so that's great. I'm going to give you some harder problems that will also be on some of the homework, similar problems that will be on the homework. So let's see what we have here. And okay, so let me think. Just make up random one. Or I can find one. Let's say 4 minus 2x over 3 is equal to 3 over 4 minus 5x over 6. All right, so please do this problem. I'll give you 5 more minutes to do this one. Since this one has fractions in it. All right, so it's a bit harder to grasp. Okay, so this one has some fractions, so make sure you know how to get rid of those fractions, right? So this one is a bit more difficult than the other ones. So I'll give you 5 more minutes to do this problem, and then we'll do one more after this.
Oh, yes.
Okay.
Okay, so let's go over this one and let's see what we got here. So who can volunteer for this? All right. Do I have any volunteers? Got a couple answers here. We have 3.5 to negative 3.5 and 1, 2, and 11 over 14. It's good to have a variety of answers, I guess. Okay, so let's see. How about Joey? Joey, can you unmute yourself and tell us how we do this?
Wait,
Okay, so how did you do this?
the second one.
Yeah, this one.
Okay. So just multiply both sides by
Yeah.
by
You have to multiply both sides, right? To get rid of the division in the fractions.
just multiply both sides by 12.
Very good. So see, this is a key point. When you have fractions like this, you multiply both sides by the least common multiple. All right. So then what do we get?
It's 16 minus.
Well, let's just do distributive property real quick. And this is going to be 9, right? Minus 2 times 5x. Okay, so now we can go to combining like terms. So what did you get?
I think
Okay, so we have 16. Okay, minus 8x is equal to 9 minus 10x. Okay, so what? We have what? We have to move 9 to the other side, right? So we have to 16 minus 9 here, and then we have to move negative 8x to the other side. So what we get is we have 7 is equal to negative 2x. So whoever got x is equal to negative 7 over 2, good job. So I don't know who got that. So if you got positive 3.5, you just missed the negative sign there. So Michelle, very good job. Okay, so let's just do one last one that's kind of similar to this, and I'll just walk you through it, and then you can ask questions after. So I'm just going to show you how to do one again with fractions. So with fractions are basically division, right? Fractions is division. So what you have to do is you have to multiply everything by the least common factor. So what we have here is, let's say 3y plus 4 over y minus 1 is equal to 2 plus 7 over y minus 1. Okay, so as you can see, we have these weird fractions, right? We don't want fractions. Fractions are hard to work with. Okay, they mess up your computations. It's a bit hard to calculate with fractions, so we need to get rid of those fractions. To get rid of those fractions, we need to multiply both sides by the least common multiple. And since both the denominators of the fraction are equal, we're lucky. We can just multiply both sides by y minus 1 to get rid of the fraction. Okay, so don't forget that we're multiplying both sides, not just this fraction, by itself. We're going to multiply this term too by by y minus 1. So after we multiply the left side by y minus 1, we get 3y plus 4 because the denominator is just simply canceled out. 2 times y minus 1 is equal to 2y minus 2, and then plus 7 here, since fractions are canceled out. Now we can combine like terms. Let's move this 2y to this other side. We have y is equal to, let's move 4 to this other side. So 4, move it to the right side here. Okay, so 4, we move it to the other side, we get negative 6 plus 7, which is equal to 1. All right. So you can plug it in, see if it's correct. And once we get y is equal to 1, right? So let me see. Did I do the calculations correct? So we moved 2y to this side, okay? And then we moved 4. Okay, so the calculations are correct. Y is equal to 1, but we are not done yet. So can anybody tell me why we are not done right now? Why is y is equal to 1 not the correct answer? So are there any ideas on why this y is equal to 1 is not the correct answer here? Okay, so the reason, okay, the reason why y is equal to 1 is not the correct answer is because we have y is equal to 1, y minus 1 in the denominator. If y is equal to 1, then this doesn't work because we're dividing by 0. So this one is actually no solution. That is all for today. Okay, so make sure you check your work if you ever have fractions like that with variables. Thank you for listening, and I'll see you next time. Are there any questions so far?
No.
Okay, if there are no questions, then I'll end it here.
All right.
Okay. Goodbye, everyone.
All right.
Please do the homework.
Bye.
I will
Thank
be
you.
up-
Bye.
Bye.